Hey guys, this is Cesar Harada for Open Sailing. Today I'd like to talk to you about how we can work together to develop the next prototype, so Protei number 6. Just as an introduction for those who just arrived in the project, so Protei is an autonomous articulated inflatable sailing robot that collects oil spill. So we got an oil spill, nasty. The oil is drifting downwind, following surface currents. Now we want to oppose this. We want to oppose this flow with an oil-absorbing material. We pull this oil-absorbing boom against the wind, up the wind, and we collect oil using the wind power. That's Protei. Protei is an autonomous sailboat that can tack upwind without losing steering nor pulling capacity. And that's tricky with a long heavy load, but we can figure this out. So all the stuff that you're seeing drawn, we actually built it already. So I recommend you check out the other video because you can see it in real. So we took a normal RC boat and we put the steering at the front. Normally it's at the back, and we got really great results. With a small direction piece, so with a small rudder at the front, we were able to control a very long tail. So that's Protei number 1. To make the steering even better, we made the whole boat articulated. It looked really awesome, and it moved like an animal, and it was curving the waters, and that was Protei number 2. It was brown. So the number 1 and number 2 are the same size. It's 1 meter high, 1 meter long. Then we thought, okay, that's really cool, but can we make this bigger and for real cheap? And if we make it inflatable, it will be very light for a very big sail surface. So we'll have a very good power ratio. And that's Protei number 3, and it's very big. It was 6 meters high and 4 meters long. And the next prototype we made, we were invited to do this art show, and so we had to present Protei as like an art installation in Korea. So we made a non-functional version of Protei, so it's number 4, whatever. And then we met this group of genius Korean kids who joined Protei art collective called randomwalks. And together we made this very tiny Protei, 50 centimeter long, filled with electronics and sensor. Protei number 5. So it could sense the walls with ultrasound sensors, and you could feel the wind speed with the hacked wind nunchuk, and the wind speed and direction, and you had a bunch of accelerometers, and so it can tell the tilt, the speed, and vibration, and all that stuff. But what's really cooler about Protei number 5 is that we also started to be able to evaluate the capacity, I mean how fast it was going. So how fast can you go depending on how much wind, what about the waves, and how do you avoid collision, all that stuff. So now we're working towards making the next prototype, so it's Protei number 6, and we want to do it with you. I mean, we're open to collaboration now, so we're launching the work on Protei number 6. So these are the properties we want Protei number 6 to have. So we're also fundraising now to buy parts. So the priorities are in this order, from bottom to top. We're trying to solve one problem at a time. Okay, so first we want it to float, so that's pretty straightforward. It needs to be like a ball, if you like. But now we want it to be insubmersible. So either the material is made of stuff that floats, or it contains air, or, light material. We want it then to self-right, which means if it tips over, it is designed in a way it will come back in place automatically. You can do that simply by adding more weight at the bottom. Okay, inflatable, well, it's, inflatables. Articulated, so it means the joints, and joints are weak points, so we have to be careful on that one. And then autonomous and remotely controlled, that means that prototype needs to be operated from a distance, somebody from the beach, for example. But the real Protei will be sailing for very long distances, like really far away, using GPS, like in the deep sea. But not for this prototype yet. And then you need to be able to go upwind, so like you understand, the oil spill moves with the wind, so we're using the same power for our machine. So we need a good sail, maybe 2 or maybe 3 sails. I mean, we don't know yet if it's going to be a 1-mast or 2-mast or 3-mast robot. And of course, we need lots of sensors on board to evaluate the machine, so the performance. So we know the capacity, and we'll be able to say, okay, if we can move at this speed against the wind, then we can collect that much oil. So that's very important. Okay. So now many people want to work together on Protei number 6 and also further versions. So how do we work together efficiently to produce that prototype? Think about it like this. To make a prototype, you need to have Okay, good design ideas. So you have a bunch of people designing cool designs and shapes and like 3D files and like physical models. Then you need to achieve some properties. So all the stuff that we talked about, like floating and self-riding and that stuff. So what the machine is able to do. And we need to always be able to build it. So the logistics. So what materials do we have? What motors, what sensor are available for our budget. So some people will work on cool design, other people would focus on sourcing the parts, and other would be like studying the math behind it, like the physics. So basically it's really a discussion between the three poles, the designers, if you like, or the architects, or the maritime engineers, or just sailors. And so that's for the design side. Then you have the logistic part, so the people who are actually like mechanical engineers, or anybody who can find some really good motors or who have some ideas from materials. And the third is basically the physicists or the mechanical engineers who will tell us, who will inform the design. So it's a discussion between the three poles, like the properties, the design, and what's feasible. So just declare what you want to do, and let's make Protei number 6 and the next ones. Thanks!